But the whole idea today is that we're going to draw box and whisker plots and then use it to compare data sets. And we want to look at those data sets as we compare the two and answer some questions about what some of the terms mean. So, to get started here, okay, we need to first of all understand some vocab. So, let me ask this question first. How many of you guys have at least heard of a box and whisker plot before? Not many of us? A few of us?
I've heard of it.
Okay, well, let's maybe talk through it. How about this, Lily? Lily, you want to read my first vocab definition up here for box and whisker plot?
Oh, I have two. What, on that one?
Right here, this top middle.
A graph that shows the median
That word is quartiles. Yep,
and extremes and the data.
quartiles. Think of it this way, guys. In our monetary system, the dollar kind of runs our world, right? How many, let me say this, 4 blank make up a $1 bill? Quarters, right? Okay. So what we're kind of looking at here today is dividing our data up into quarters, all right? What's a quarter worth monetarily?
25 cents.
25 cents. So we're going to be breaking up our data into 4 different sets. And each set's going to contain 25% of the data. So isn't 25% really a quarter of something? Would you guys agree with that? 25% is a quarter of something? So we're looking at breaking stuff up in quarters. So yeah, she's right. It's a graph that shows, first of all, the median. What's the definition of median again? In a data set, it would be the number in the middle. Okay? The quartiles, I'll talk about what that means here. And then we're also going to talk about extremes. When we talk about extreme temperatures in Iowa, what am I talking about?
Oh no, like 90.
It's either extremely hot, the highest temperature, or in the wintertime it can be extremely cold, which is not too far off for us right now, right?
I'm not sure.
Okay, so the extremes are basically going to be something we talk about. Let's talk about the quartiles first of all here. I'm going to volunteer to read my definition of lower quartile for me. Who can read that? Go ahead, Larry.
Median of the lower half of the data set.
Okay, in the data set, we're going to have a set that's the upper half of values and the lower half of values. We're going to break them into 2 halves, all right? If this is my bottom half down here, we're saying the lower quartile is the middle of the lower half. So what's that going to mean for upper quartile? I have the upper half of data right here. What's the upper quartile going to be? Well, isn't that going to be the middle of the upper half? You guys agree with that? You're going to take your data and split it in half. The lower quartile says it's the middle of the lower half. All right? It's kind of like taking a cake. Cut that cake in half. All right? I have half a cake. You have half a cake. Okay? I'm going to tell you to take your half of the cake and cut it in half. Now you've got a quarter, right? All right? Very good. Upper quartile, same thing. It's just the middle of the upper half. And I'll show you what this all means here. So, kind of up here, gang. Look at this chart right up here, would you? In our illustration for a box and whisker plot, you have this number line right down here, okay? And what it's telling us is this. In this data set right here, we have some extremes. What are my extremes in this right here? What values are my extremes? What's the lowest value that's plotted right here? What's it correspond to down here? 3. What's the highest value? 18. Now, we said we have a median. And a median right here, looks like this median corresponds to what value? Does it look like it crosses down there? What's that median appear to match up with? 10.5, okay? Then, here's the deal. If 10.5 was the middle of the data set, in the upper half right here, 10.5 and up to 18, we're saying that the middle of 10.5 and 18 is right here at what value? What's this say right here, gang? What's it say? What's the middle of the upper half? 15. And that 15 represents, what's the word up here? Upper quartile, all right? Over here, what appears to be the middle of the lower half of data, or in other words, the lower quartile? What value does that appear to be? What's that appear to be? Anybody? 4. Okay, so this is all self-explanatory up here, what these numbers mean. The far left number will be your lower extreme. This number here will be your lower quartile. This will be your median. This will be your upper quartile, and this will be your upper extreme. Okay, and again, last set down here, extremes. We already talked about the extremes are the lowest and the highest values in the set. All right. So guys, some of the information that's given to you, today, over here in these examples about the definitions, this is pretty important. So you might want to box this in or highlight it. But that's pretty important information right there in that column. Okay. All right, so let's look at an example right here about constructing a box and whisker plot. Notice in example 1, it says, construct a box and whisker plot of what kind of sets here? What kind of sets does it say right here? What kind of a set am I talking about?
Even.
It's an even set, okay? When I say even set, that means there's an even amount of data in the set, all right? So right down here, this example says the following. It says 18 basketball players practice free throw shots on 2 separate days, all right? It says the number of shots made out of 50 by each player is shown below. Our job here is for the following, day 1, day 2. We want to come up and figure out a lower extreme, a lower quartile, a median, an upper quartile, and an upper extreme, all right? And what we want to do is we want to use those values to compare the data on a numbered line that we're going to look at on the second page. But here's the deal. In order for this to work successfully today, we've got to make sure we reorder the data from least to greatest. As it stands right now, are we in that situation? Am I listed from least to greatest right here, or is it out of order? Kind of mixed up. So I need your help here, all right? I need your help with this. So let's go ahead and get this reordered first, and you want to write this down as well. So help me out. I'm going to make this a bit bigger. Hopefully I can squeeze it in there. Yeah, that's going to work. Good, good, good. Okay, for day 1, let's roll. On day 1, what's the smallest value in that data set appear to be? I got a 12 here. So it looks like 12 is the lowest. All right, so I'm going to cross this out. Okay, you keep helping me on this. What's next?
13.
Oh, where is it? There it is. Okay, so 13 is my second one.
16.
Oh, so 15 and then 16, is that right, gang? Okay. Now again, in order to do this, we've got to put these values in order first. 15, 16. All right. 25,
23.
23, okay, 23, then 25 and 27, are those the values in the 20s?
Yeah.
23, I saw 25, where was it?
My 16.
Oh, there we go, 25, and if you're ahead of me, you can start shouting them out, okay?
32.
What's after 27?
32.
32,
34. 35.
34 you said?
34, yeah.
34, 35,
36. 548.
there we go, thank you. 36,
38. And then 39. 42.
42, 43, well, there's 2 42s, aren't there?
Oh, yeah.
2 42s right here and here. Is there a 43 after that?
Yeah. Yeah.
43,
48. 48
and then the last one's 50?
Yeah.
Okay, so let me squeeze that in over here. All right, so how many free throw shooters were there in this problem, guys?
What?
What's the problem say at the very beginning? First word in that example.
18.
So I better go through and make sure I have 18 values now. Here's the deal. I like to go back and count my number of values that I reordered, because if I screw one of them up, it's going to mess everything up for you. So when I go through and count my data that I've reordered, there should be how many values here? All right, let's check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Good. Very good. All right. So let's talk about what we're doing here, gang. Kind of abbreviated some stuff down here in terms of what it is we're supposed to do. And the first thing that we said to do is to find all these values and then plot them on a number line to form a box and whisker plot. Okay? What do you think this abbreviation LE stands for? Lower extreme. So the lower extreme being which value? 12. It's the smallest value. I like to do the extremes first. So what is the lower extreme? Well, you're going to tell me it is 12. So if I know the lower extreme, can we quickly identify the upper extreme in this data set? 50, right? Extremes are pretty easy, aren't they? All agree? All right, here's where things get kind of tricky. We need to find the median next, okay? Now medians for odd data sets and even data sets differ. In an odd data set, the median will always be there, but in an even data set, like we've looked at before, the median will be something we have to generate, okay? If I have an even data set, in this case 18 different numbers here, if I have 18 different numbers, where's the very middle going to be of 18 numbers? Give me 9. It'll be 9 numbers to the left and 9 numbers to the right. So I want to count in here, right here. I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9. Looks like my median is going to fall for this even set between 34 and what? What do you have to do to the 34 and the 35 if you need to generate a median in a data set? We've done this already. What do you have to do with the 34 and the 35? Add them up and divide by 2. Yeah, in an even data set, we can't just use 34 or 35. We've got to average them. So somebody average 34 and 35. What have you got? You working on it, Larry?
Yes.
Or in other words, where's the middle of 34 and 35? 34.5. Okay, so the middle value, 34 and a half. All right. Everybody okay with that? Was that value listed or was that value generated? It was generated because our set is what kind of a set here? Even set. Okay, now, lower quartile. Somebody read the definition of lower quartile again for me, please.
Median of the lower half of the data set.
Okay, do you guys agree that right here, let me highlight my lower half. You guys agree that my lower half is right here? Lower half of the data set right there. How many numbers are in that lower half? Is that lower half an odd or even value? It's odd all of a sudden, right? Lower half is odd, so will the median be listed or generated this time? It'll be listed. It's the number right in the middle. I'm going to count 1, 2, 3, 4, 5. Check it out. I think it's what value? 23. Watch this real quickly, would you? I draw a line under 20. How many numbers are right there? How many numbers are to the left of 23? 4. Okay? So what's the lower quartile value? 23. Okay? All right, so over on the right side, if I circle this right here, I think the median's 42. How many numbers are to the left? In that upper half, how many numbers are to the left here? How many numbers to the right? What's my upper quartile? 42. Okay? All right. You understand how I got these numbers first of all? Jaden, question?
Never got
Okay, everybody good on that? All right. What I would like you guys to do is take a minute, go ahead and do the second set just like I've done the first set, okay? So what's the first thing you need to do with the second set of data right here? What's your first job?
10-minute order.
Reorder it, okay? And then we'll work to find these together. So what I want you to do is take a couple minutes, reorder them, find the extremes, find the quartiles, find the medians, and then I'll kind of explain to you what's going on with all of these values and what we're going to do with them, okay? So I'm going to go ahead and be writing them down up here. You do the same thing. Go through and find these 5 values. Once you've got those 5 values, check it, okay? am I doing?
Good.
Okay, do you guys agree with my order first of all?
Yeah. Yep.
Better check and see how many values again? 13, 14, 15, 16, 17, 18. I forgot a comma between the 29 and 31, didn't I? Okay. All right, so let me go in there and fix that.
2,931.
Yeah, I gotta fix that, don't I? Okay. So what'd you guys come up with for extremes here? So lower extreme is 14. How many had 14 on that? Okay. Then what's next? 42 is the upper extreme. Okay. Now, I talk an awful lot about even and odd sets. I say this is an even set simply because there's 18 different data in there. So will the median be generated or will it just be listed there? Generated. So what two numbers am I generating that between? 5, 6, 7, 8, 9. So between 21 and 26. So 21 and lower is the bottom half, right? 26 and above is the upper half. So here's the deal. If you were shooting free throws on day 2, if you were anything 26 or above, you'd be in the top half of free throw shooters, right? If you were below 26 or 21 or below, you would be in the bottom half or the lower half, okay? What did you guys generate as a median between 21 and 26? 23.5, I agree. Now, that's quartiles. You look at them as two sets. You look at the lower half, you look at the upper half. What's the middle of the lower half now? 18 right here. Let's just check it and see. 18 is there. How many numbers to the left of 18?
4.
How many numbers to the right?
4.
So was 18 the middle of the lower half? All right. Kind of want to explain to you what's going on here, guys. Here's the deal. Basically, from 14 up to 18, and from 18 up to your median, how many parts do I really have here? How many parts a day do I have when I split it up like that? First part and a second part, right? Okay. If from 23.5 down was the bottom half, that's 50%, isn't it? What's half your 50%? What's half 50%? 25%. So this first part right here, anything from between 14 and 18 meant that you were the lower 25% of the shooters. Then, from 18 up to 23 and a half, that would be the next 25% of shooters. What'd you guys get for an upper quartile?
34.
34. If you shot anything between 23.5 and 34, that meant you were in the third quartile. And then over here would be the fourth quartile. So it goes first quartile up to here, second quartile to the median, third quartile to that upper quartile of 34 that I'll write in here. And finally, the fourth quartile is from 34 up to what? 34 up to what? 42. So I highlight these here in different colors, all right? My first quartile goes from 14 up to what? Well, up to 18. And then the second quartile is going to go from 18 up to 23.5, our median here. You guys okay with that? Then the third quartile goes from 23.5 up to what? 34. Now what's the last quartile going to go to? 34 to what? 42. Okay. How many different colors do I have up here? 4. Okay. This just represents 25% of the data fell from 14 to 18. 25% of the data fell from 18 to 23.5. The other 25% of data fell from 23.5 up to 34. And the highest 25% of data fell between 34 and 42. Okay, first of all, do you understand what I'm talking about when I put them into 4 different intervals like this? Don't care what the numbers are. I'm simply caring about how many sets of, or I'm sorry, how many values of data are in each set. And these are listed by quartiles. 25%. Okay? Good there? All right. Let's look at what this looks like graphically. And you guys, can you refer to these numbers for me right here? Flipping back and forth. Can you guys do that for me? What we're going to do, can you refer to these numbers? Have you got them down?
Yeah.
Okay, here's what I want to look at. What's this look like graphically? Okay. Day 1, day 2. I have that day 1 data. I want you to help me plot this. All right? What did we say in day 1 that our lower extreme was? On day 1, what was it again? 12. So I'm going to come in here and I'm going to plot 12, which would be right about here on my number line. Everybody agree with that?
Yeah.
All agree? Okay. Secondly, what was my lower quartile then? 23. So I'll put 23 as my lower quartile, say right about there. What do we get as a median on day 1?
34.5.
34.5. So that's about right here in the middle.
And then 42.
42 was the upper quartile.
Yeah.
And how about my upper extreme?
50.
50. Okay, here's the dealio. When you form a box and whisker plot, basically your box is the middle half of data. Okay? Or in other words, the box is the part that goes around the medians. If you look at your notes back on the first page, do you have those values plotted, by the way? Yes? No? Yes? Yeah? Good, Cash? Okay. Right here, if I look at this right here, we said the box is going to be the part that goes around. What are the 2 words they use right here? What's the box go around? What 2 dots? What are these words I'm pointing at? The lower and the upper quartile. So if I go back to my graph right here, you're simply going to place a box around your quartiles. And your quartiles are going to be the 2nd and 4th one right here. So here's the dealio. What I've done is I've marked off the middle half of the data. The middle half of the data falls between the lower quartile and the upper quartile. So in this example right here, guys, what percent falls between dots? Well, each time it's 25%, you told me, right? So in this box, what percent of the data is contained within this box? There's 2 intervals right here that we marked off. So what's 25 plus 25 going to be? 50%. So 50% of the data is in this green box right here. 50% of the data. Okay, now your whisker part's out here to the left and to the right. This is going to represent the bottom 4th of your data, and it's going to represent the top 4th of your data. So there's 25% of your data out here on this left whisker. And what percent's out here on this right whisker? Well, you'd say 25%. So listen to my questions. What percent of the data lies in the whiskers? The whisker part, how much? 50. 25 on the whisker on the left and 25 on the right. Okay? And then this middle box contains the middle 50% of your data. Okay? You understand how I formed that graph with the data? Plot the lower extreme, plot the lower quartile. What's this number represent again? What's this number represent again? What is it, John? So median, this is the upper quartile, and this is my upper, what's this last value on, right? Upper extreme, okay? All right, how many plot the data for day 2 then? Okay, so go back to your data right here. I'm looking at these numbers right here. Day 2, help me plot this data, and I want to kind of make a comparison right here about what's going on. So, from the day 2 data on the first page, whoops. From the day 2 data on the first page, what, whoops, I didn't want to do that. What was the lower extreme on the day 2 data? Lower extreme was 14, so I'll plot that about here. What was lower quartile? 18, so 18's right, ooh, that's kind of a short whisker, isn't it? 18, all right, how about the median?
23.5.
23.5, what's the next one? Upper
34.
quartile, how much?
34.
Upper quartile is 34, so right about here, between 30 and 40. And what's the upper extreme?
42.
42. All right, so I'm going to put a box again around my quartiles. This represents the middle, what percent again of data? That's the middle 50%. And then I'm going to put some whiskers out here for the upper quarter or upper 25% and for the lower 25%. Okay, here's the deal. If I had to ask you a question based on these 2 graphs right here, day 1 or day 2, which day looked like a more productive day for my free throw shooters of my 18 players? I'm here saying day 1 looks like it's a little better. Again, free throws, good when you make them, right? We're charting the number of makes for certain people. Which of these 2 data sets right here looks like we had a better day, day 1 or day 2? Why the first day, Haley? Stuff has moved more to the right, meaning we've made more shots, right? Okay. So I would agree. Isn't my extreme higher here than it is here? So the most of me here. How about my upper quartile? Which day is higher? First day or second? Hello, guys. Earth to students right now. Tune in. Let's go. Which one's higher? First one. Which one's higher here for the medians? First one. What's higher for the lower quartiles? Okay, the only thing that's really different here is the lower extremes, aren't they? They're about the same, aren't they? Okay, so which day would you say had a better day here? Okay. It's not difficult, all right? All right, quickly I want to look at an odd data set here. Just to show you what the differences are in an odd data set and kind of alert you to some troubles that you can run into, all right? The daily high temperature for each day of the week for Chicago is listed below. We're going to construct a plot for these values. So quickly, help me reorder these. What's the lowest value here? 78? Is that right?
Yeah.
And what?
79. 82.
82. So you guys be reordering these as well. 83. An 85 and a 95. Okay. Guys, what kind of a set are we talking about up here now? What kind of a set am I talking about? It's an odd set, not an even anymore. So it means there's 1, 2, 3, 4, 5, 6, 7 values for my data. 7's odd, right? So there's 7 different numbers. All right, first of all, lower extreme, what is it? 78. Okay, what's the upper extreme? 95, good. Okay, now is the median going to be listed this time or generated? Listed here, okay? It's going to be listed because my set's odd, so let's find the middle here. Would you guys agree 82 is right in the middle? 82 is right in the middle because how many values are to the left? And how many values to the right of that? 3. So 82 would be my median, wouldn't it? Okay, so here's 82 as a median. All right, how about the lower quartile? Do I have to find the lower quartile, generate it in other words, or is it listed? It's what? What number is it, Haley?
79.
What's my upper quartile?
85.
Okay, so help me plot these values down here. Lower extreme, you know, this is going to be kind of hard to do, but the lower extreme of 78 would be, I'm going to change my values down here. You'll want to do the same. Let's do this. Let's just get rid of these values down here. I'm gonna cross all these off. You do the same here, all right? Actually, I have a better idea.
Just make it.
I got a better idea. Let's just do this. Watch what I do here.
You make a box. It's gonna be white.
Mm,
Mr. Parsons?
Yep. Yes.
You sent Delaney shares to the office.
She's
She'll
on
be
her
leaving.
way. Laney, grab a page 160 up there. That'll be due Thursday. It's in one of those baskets. I'm gonna put put 50 right here. 60, please work. 70, 80. Yeah, this will work. Go 90, and then 100 right here. Okay. All right. So what did we say the lower extreme was, gang? 78. Okay, so we have got these numbers. They're kind of by fives. So it goes 50, 60, 70. All right, so 78. Let's see. If this is 70, this would be 75. So wouldn't 78 lie right about here, everybody? And then what's my lower quartile? No, it'd be 79, about right there. Okay. 82 is the median, so 82 would be right about here. What's the upper quartile? 85. And then 95 would be my upper extreme. Okay, so I want to put the box around the quartiles. Oh no. Oh no. Better fix that, huh? Not good, not good. Is this better right here? Oh. Hey, cooperate. There we go. Hey, I have a question here. 25% of the data is in the whiskers, right? Which whisker, the lower quartile, or I should say the lower 25% of data, or the highest 25% of data, which quartile has a smaller range? The one on the left or the one on the right? It's a lot shorter, isn't it? Okay. All right, real quickly. Can you guys construct these, first of all? Can you construct these? Should be able to, I think. Okay. Any problems with that at all? Basically, it's just a matter of ordering the data from least to greatest, finding the outside values, finding the middle value, cutting your data into two halves, and then find the middle of the upper and lower half. Okay. All right. So the last page, real quickly, I want to run into this right here, guys. What does this stuff tell us? Well, I already told you right here that from dot to dot, from extreme to quartile, there's 25% of data in that whisker. Okay. Then in this one right here, from dot to dot, there'd be 25% of data here. From the median to the upper quartile, 25% of the numbers in the data set fall from between those two values, and then finally from the upper quartile to the upper extreme, 25% of data is going to fall there. So look at some of these questions right here. It says, what percent of the data lies above the what here, gang? What percent lies above the what? What's the word? Median. Well, the median's right here, so from the median onward, how many different 25% intervals do you have?
50%.
You have two of them. So what percent lies above the median? You would say 50% here, right? Raise your hand when you know the next one. What percent of the data lies on the whiskers? Nobody knows?
50.
Megan, help me out. Okay, 25 on this whisker and 25 on that whisker. So totally on the whiskers, what percent do I have? 50, right? Good. Listen to the question based on the sample that's up here. What percent of the data is between the value 4 and 10 and a half? Let's see, 4 is here, 10 and a half is here. Correspond to those dots. So what percent of the data is between those two?
25.
25%. Raise your hand when you know the last one. What percent of the data is below the number 15? Megan, got it? 75, yeah, 15's right here, right? So 15 is this upper quartile. What percent lies below? Well, there's 1, 2, 3 different intervals that lie below 15, right? So 3 25% intervals would be what value? 75%. Okay. What questions have you got on this? Anybody have questions here on this? Okay, let me get you